Hi, I'm Assam, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 29, Questions 79 to 80. And in this unit, we're going to take a look at some models being developed to explain the different patterns of resistance to pathogenic microorganisms. So we've got uh, 5 factors that are assumed in these models. But if you take a look at questions 79 to 80, we only really have to focus on factors 1, 4, and 5. So we can kind of ignore factors 2 and 3, so we can obviously save time in our exam, so we can answer other questions and get through this question. Now, this question, ACE is being a bit funny here because this can actually be a section 1 question because a lot of answering, well, the skills required to answer this question requires comprehension of what you're reading. It's something you'd see in a section 1 unit. However, it is here in section 3. I mean, it does have some science behind it. And let's just consider some points when we read the factors. So if we read factor 1, so factor 1 says the duration of the contagious period of infected individuals. Now, if the duration of contagious period of infected individuals is long, you know therefore that the treatment for infections will increase, and we're going to have more resistance because if you're treating more people, if you're treating for the disease that has a long period, you're more likely to get resistance. So factor 4 says the degree to which development of resistance reduces the competitive fitness of the pathogen. Now think of it this way. So what that means is that let's say in high resistance scenarios. So we don't want to reduce the competitive fitness of pathogens in high resistance scenarios. So you'd actually want this to be low in high resistance scenarios, because if it was this value was high, that means we've reduced the competitive fitness of the pathogen, so therefore the resistance will be low. So that's why in situations where we want high resistance, we don't want to reduce the competitive fitness of the pathogen, and we need this to be low. The reason why I'm saying this is because it kind of relates to the next couple of questions coming up. And lastly, it's very obvious. It says the probability that a drug-sensitive microorganism becomes resistant when treated. Well, if the probability is high for resistance, the pathogen is more likely to evolve resistance and vice versa. So let's take a look at the first question, 79. It says, with all other factors held constant, in which of the following situations is contagiousness most likely to lead to resistance? So we're trying to get resistance here. So 1 and 4. So let's focus on 1 and 4. We're trying to get resistance. So for factor 1, it's a duration of contagious period. We want that to be long because, again, if the contagious period is long, it means that the treatment for infections will increase. You're going to keep treating them for drugs, which means you're going to increase the resistance, or it's more likely to increase because you're going to keep trying different drugs. So that's why for 79, so 1 has to be long. So we know therefore C and D are incorrect. So either 4 is going to be high or 4 is going to be low. So this is the trick here. Remember, if we want to keep resistance low, we'd want 4 to be high, because the degree of which development of resistance reduces the competitive fitness of the pathogen. So if we have, we don't want to, in high resistance states, we don't want to reduce the competitive fitness. So that means this number 4 for resistance has to be very low. So that's why 4 is low. So we know 1 is long, 4 is low. So therefore the answer for 79 has to be B. So it's one of those you have to wrap your head around. So I'll say it one more time before I move on to 80 because it's important to note. Factor 4, if resistance, if we're reducing the competitive fitness of the pathogen, remember, we want to increase the competitive fitness for a pathogen so that we can increase resistance. However, for 4, we're saying we want to reduce the competitive fitness. If we're reducing competitive fitness, we're reducing resistance. So if we want to increase resistance, we have to keep that low. That's why 4 has to be low, because we don't want to reduce competitive fitness. We want to increase it. So that's why 4 has to be low. So try to wrap your head around this. So I think it'll probably make sense now if we get to 80. Hopefully it'll make more sense once we get to 80 now. So it says for genital herpes, there is a long contagious period, reduced fitness of the virus after it becomes drug resistant, and a low probability that the treatment will lead to resistance. And influenza A, there's a short contagious period, no reduction in fitness, and a high probability that the drug resistance will develop. Compared to influenza A, genital herpes is most likely to evolve resistance. So let's just write it down. So we've got genital herpes, we've got influenza, so let's say influenza A. So let's just say, put it up here. So what do we got here? Contagious period. So we know that it's going to be long for our genital herpes, short for influenza. We'll come back to this one. Let's say our probability of resistance is going to be low for our genital herpes and high for influenza. So the middle one is obviously the fitness. Okay. So remember, we're being asked for options 1, 4, and 5. So remember, the contagiousness is option 1, the fitness is going to be option 4, and the probability of resistance is option 5. So recall this. So fitness, so it tells us for our genital herpes, reduced fitness of the virus after it becomes drug resistant. So that means we're going to have well, if it's a reduced fitness, that means 4 was high, because we had a reduced fitness after drug treatment. So that means that obviously the drugs are working and we've reduced the competitive fitness, so we've got a high value here. Whereas for influenza, it says there's no reduction in fitness, so no change. Which you could say if there's no change is obviously going to be lower, so lower than our GH. So therefore, if compared with influenza A, genital herpes is most likely to evolve resistance because of, well, it's going to evolve resistance whether more quickly or more slowly. So let's have a look. It says more quickly because of both 1 and 4. So more quickly, so resistance 1 and 4. Well, no, because the fitness here for 4 is high, so that means the competitive fitness has been reduced, so therefore it can't be A. B says more quickly because of both 4 and 5. So it says 4 and 5, so 4 is the fitness, and the probability of resistance so is low, so no, it's not going to be B. So it's kind of like, so we know it has to be either C or D. So it's going to be more slowly because it says more slowly because of 1 and 4. So no, because we've got a long contagious period. That's not going to affect it. More slowly because of 4 and 5. Well, 4 is a, yep. So 4 has a high fitness, which means it's going to be more slowly, because if it has if the competitive fitness has been reduced and the 4 value is high, that means resistance is going to be less likely, because in high resistance scenarios, we want this to be low. So that's correct. And then 5 says because the probability of resistance is low. That's why it's going to be less. So yes, because the probability of resistance is low, therefore the resistance is going to be slower. So that's why D is correct. Just got to double check. Please be correct. Yes, it is correct. So 80 is D. So process of elimination, we figured it out. So I think the key here is just noting that I think 4 was the problem here. So factor 4 would have thrown off so many people, because it's like a double negative pretty much. They're telling you that if you reduce the competitive fitness, which means you're going to reduce your resistance, it's going to be high. Whereas if you're going to if you don't want to reduce the competitive fitness of pathogens, so we want this to be low. So that's why the answer has to be D. It's just trying to wrap your head around this. I know this should be probably a section 1 question because it is a lot about comprehension, but I mean, it's there and you've got to answer it. If you're still having trouble with this unit, you can post your queries in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.